NCBM 0324, Section 1.4, Evaluating Functions Using Function Notation. Part 5. So we've been practicing evaluating all kinds of situations, numbers that are both positive and negative, maybe another letter that we needed to use, another variable, maybe an addition of a couple of variables with that x plus h. Well, let's see how we can now use multiple functions within one problem. Right? Let's work with a couple of them at the same time. In example 2, we want to use the given functions c of x and r of x to find the following. So we have a new label for our functions. We have this capital C, capital R, but otherwise they're going to act in the same way. They are still functions. So when we see this c of x, this is the y value for this particular function of c here. So we have c of x is equal to 600x plus 4,500. And we have r of x is equal to 750x. So those are my functions that I'm working with for this particular example. And in part A, they're asking us to find c of 20. So c, I'm using my c function here. My x value, what am I going to plug in? Well, that's 20. So if I start with my skeleton, there's my blank space, because that's where the x was. 4,500. This x is this blank space here. And the problem is telling me to plug in 20 into that space. Well, if I multiply this out, 600 times 20 is 12,000 plus the 4,500. We're going to end up with a value of 16,500. So that's my c of x. Right? That's actually it's my c of 20. When my x value is 20, the y value for that c function is the 16,500. Part B. Now we want r of 20. So now we're looking at the r function. So wherever there's an x in the r function, I'm going to plug in the 20. So for r of x, we had 750x. So 750 times, there's my skeleton, times my substitution part. And what do I fill it in with? The 20. So in this case, we're going to have r of 20 is equal to 15,000. All right, pretty nice. Big numbers, but we can find these with our calculators. Let's keep going. Part C, we're looking for r of 20 minus c of 20. So we're using both now. We're using both the function r and the function c. Now they're both being evaluated at 20, which that's great. That's pretty interesting. But what's more interesting is that we would have to find these values first and then do the subtraction. Remember, this is not a regular parentheses of multiplication. We can't, factor out the 20 and just do r minus c. That wouldn't have any meaning here. This r of 20 we just wrote is equal to a number. In fact, I'm simply going to plug in that number to find my answer here. So r of 20 was the 15,000. Minus, what was our c of 20 answer? C of 20 was the 16,500. So when we subtract these, our answer is still a number, right? So that's our answer for part C. So what we basically ended up doing, because we had already calculated r of 20 and c of 20, we already made that substitution for each of those. It's just a matter then of subtracting our values. So we did the operations and then we just subtracted. So that's pretty straightforward, right? Find each of them and then work with the values, with the answers. What about part D? In part D, we have now a new function. Remember, we only had c of x and r of x. Now we have a p of x, capital P of x. But they're telling us that p of x is equal to the r of x function minus the c of x function. So r of x minus c of x. I don't have any numbers, so I know my answer is still going to have the x variable in it. But let's see what that's going to turn out to be. So our p of x, what is that going to equal then? Well, what was our r of x? It was 750x. So I'm going to replace that r of x here with the calculation that we used to find it, the 750 times x, minus, well, how did we find the c of x function? Well, that's the 600x plus 4,500. And I have this so far. Now I'm going to pause here really quick because there's something important that I've missed when I wrote that c of x function down. When I read this, when I say minus c of x, this means I have to subtract all of the c of x function. So I'm not just going to subtract the 600x, but I would also have to subtract whatever comes after it. So to keep track of all the parts of that the subtraction, I use parentheses to denote that all of this is being subtracted. And that parentheses is important because what happens with a minus and parentheses, it's going to flip the signs, right? It's going to be distributed in so that we have p of x is equal to 750x minus 600x minus 4,500. So it's easy to miss that part. So be careful with subtraction of functions. Whatever is in that function, you have to make sure it's subtracted all the way through. So those parentheses after that minus help us keep track of that. Once I have that subtraction distributed though, I can combine some like terms. So this new function p of x is equal to, I'm going to combine here the 750 minus the 600, x of course, those are x terms. So that ends up giving me 150x minus the 4,500. So there's that new function p of x. And how do we build it? We use the r of x and the c of x. Last part, part E. We now want to find p of 20. So using this new function that we just finished creating, the 150x minus the 4,500, I'm now going to evaluate. I'm going to plug in a number. Maybe I'll use one more different color highlighter. So into the x spots, right into my skeleton, what am I going to plug into that blank that we created with the x here? We're going to plug in the 20. That's going to match there. So I can have that p of 20 is equal to 150 times 20. Well, that's 3,000 minus the 4,500. And I can combine those, subtract them. 3,000 minus 4,500 gives me negative 1,500. There's our last answer. Which, by the way, you may or may not have noticed, is the same answer from part C. So I wonder if they're related.